SAP Landscape Management Cloud is a new software-as-a-service offering to help customers manage and run their SAP systems efficiently on public cloud infrastructures. In this video, we'll touch on the key capabilities of the solution. Let's start with the dashboard. The dashboard provides a general overview of the landscape using various tiles. The estimated monthly cost shows the estimated cost of running your landscape as a whole and each system group's share of that cost. In our example, 55% of the estimated monthly cost comes from the production system group, and the remaining 45% from the other groups. System groups are used to organize systems by category, as we can see at the bottom. In this case, we have 4 system groups, and the respective systems are assigned to them. In the Applied Patterns tile, we see any cost or energy optimization patterns that are currently active. At the moment, we haven't applied any patterns. The same is true for the estimated monthly energy savings and annual energy savings tiles. We haven't applied any energy optimization patterns here either, which is why these tiles do not contain any information. We'll return to these tiles later in the video. Now that we've introduced the dashboard, let's go to the Operations tab and see how system visualization works. Let's select System P00 from the Production group and then the Graph tab to open the visualization view. We can click on Enter Full Screen to have a larger view and then choose Zoom to Fit so that it fits perfectly to our screen. Visualization provides a top-down graphical view of our entire system that helps us understand which instances belong to it, their dependencies, and which virtual resources the instances are running on. You can also see the current status of our system. Here the status is green for all the associated instances and resources, which means they are running normally and without any issues. If you prefer a horizontal view, you can easily switch the layout by selecting the left-right view from the drop-down menu and then choosing Zoom to Fit so it fits your screen. Now let's see how to perform operations on the managed systems. In our example, from the production group, we will select a system that is running and perform a stop operation on it. First, select the system, then choose Operations and select the stop operation from the drop-down list. A new window appears that contains a list of all the instances that will be stopped by this operation. Choose Next to review all the instances and their dependencies, and then choose Perform Operation to stop the system. On the next screen, use the forward arrow on the right to open the Activities view. Here you can monitor the status of your operation. Once it's finished, the status changes to Completed. If you want to review the operation in detail, you can navigate to the Activities History tab on the left and select the operation you just performed. This will open another view where you can see a list of the steps that were performed during this operation. The Graph tab shows the steps as a graphic. You can also perform a mass operation on a group of systems, which you might want to do in a maintenance window, for example, when you need to start and stop multiple systems. So, let's go back to the Operations view and see how it works. You can use the System Group filter at the top to select a group of systems for the mass operation. Here we will select the Development System group and perform a mass stop operation on all the systems that belong to this group. Once again, a new window opens where you can review all the instances and their dependencies and trigger the mass stop by choosing Perform Operation. Now you can go to the Activities History view to check the progress of your operation. Once it's completed, you can go back to the Operations view to check the status of the systems. As you can see, all the systems in the Development System group have been stopped. Now that we've seen how to perform basic operations on SAP systems, let's look at more advanced operations. For example, an SAP system refresh to update a non-production system, such as a quality or development system with the latest production data. Here we're going to refresh one of our quality systems. After selecting the system, we need to scroll to the right, click on the 3 dots, and choose Refresh System. This opens a guided workflow. The first step is to choose the correct source system from where we would like to refresh our quality system. Next, we need to provide some information such as the path to the data backup created from the source system and the ABAP database schema's username and password. Once we've done that, we can move you to the next step. Here we can see the list of allowed outgoing connections on the target host. To open a new connection, choose Add. network isolation is performed on the target system. This is to avoid any conflicts or issues by ensuring there is no outgoing communication to the source system or any other related system in the landscape. The next step is post-copy automation, where you need to select the ABAP client in which you want to execute the system refresh task list. This is typically client 000. You can also provide a task list variant of your choice. SAP Landscape Management Cloud uses this information to automate all your post-refresh manual configuration tasks, which significantly speeds up your system refresh activities. In the last step, you can review all your entries and start the system refresh operation by choosing Perform Operation. You can then go to the Activities History tab to monitor the progress of your system refresh operation. By choosing the arrow, you can display a list of all the steps that are performed in this operation. SAP Landscape Management Cloud also helps you optimize the energy consumption and cost of your SAP systems that run on public cloud infrastructures by letting you create unique optimization patterns. So, let's see how they work. First, go to the Optimization tab, where you'll find all your system groups. Since non-production systems do not need to be available around the clock, they are a good place to look for energy and cost savings potential. In our example, we want to apply an optimization pattern to our quality system groups. So, we select the quality system group and then select all the systems that belong to this group. Next, in the Operations menu, we choose Apply Pattern. On the Apply Pattern screen, you can either choose a default pattern or one of your customized ones. Let's choose a default pattern called Workdays Running 16 Hours. It keeps the quality systems running 16 hours a day during the week and shuts them down on weekends. Once you've chosen a pattern, you can start analyzing the energy and cost savings that you can achieve by using it across various time frames, ranging from 1 week to 1 year. So, let's go ahead and apply this pattern. You can now see under the optimization column that the new pattern has been applied, and it already shows the reduced estimated cost next to it. Now that we've applied some optimization patterns to our quality and sandbox systems, let's go back to the dashboard to see what information is displayed there. As we can see, our estimated monthly cost has been reduced from €36,000 to €28,000. We can also see how much energy we can save monthly and annually by using these optimizations. Now let's see how we can analyze our infrastructure spending by using the analytics in SAP Landscape Management Cloud and the insights they give us to further optimize our running costs. When you go to the Costs tab under Analytics, you see different views such as the Landscape view, the Region view, the System view, and so on. You can use these views to analyze your infrastructure spending in different ways. In this video, we explored the Landscape view and System view. The Landscape view contains various filters. In our case, the Date filter has been set to current year. We have 2 cloud accounts, one for AWS and one for Azure, as you can see under the Account Name filter. Our systems are deployed in 2 regions, EU Central and EU West, which are listed under the Region filter. We have 4 systems in our cloud landscape, as shown under the System ID filter, and so on. You can use these page-level filters to define your landscape view. Below, the Show Costs By view lets you slice the data and look at it from different dimensions. The default dimension is Region, and you'll notice straight away that the EU Central region is generating the most costs. If we change the dimension to System Group, you can see that the AWS System Group is generating higher costs than the Azure System Group. Let's go one level deeper and change the dimension to System ID. We now see that System AWA, which is in the AWS System Group, is generating significantly higher costs compared to other systems in the landscape. By clicking on the line chart for System AWA, you can see additional details. Now let's switch to the System view for more data about System AWA. We can use the System ID filter to look at System AWA only. We notice 2 things straight away. First, the tenant database instance HDB is generating the highest cost. And second, The compute costs are significantly higher than the storage costs and account for most of the system costs. If we apply the resource type filter, we can narrow the data down to the compute resource costs. We can see below how use of the system peaked from February to May, which may explain the significant increase in the compute costs. Now let's look at the Energy Consumption tab under the Analytic to see what information is available there. On the left is an overview of total energy consumption and savings for the current year. On the right, you can see the estimated energy consumption for each quarter. The blue bar shows the estimated energy consumption without any optimizations. The orange bar shows the actual energy consumption that you could achieve if you used certain optimizations. This of course varies depending on which optimization patterns you have applied. The green line graph shows the estimated energy savings per quarter. Below it you can see your energy consumption data for different dimensions such as region. You can change the dimension to System Group, or go one level deeper and change it to System ID. Now let's look at System AWA only, which we analyzed earlier, by filtering by the System ID to obtain a breakdown of energy consumption and savings for this particular system for each quarter. By choosing the instance type dimension below, you can see the energy consumption and savings for each instance of this system. We hope you enjoyed watching this video and that you now have a good understanding of some of the key capabilities of SAP Landscape Management Cloud. Try it out for yourself and let us know what you think.